All right, here we go. So we got arc cosine of negative 1/2. So remember that arc cosine or inverse cosine, whatever you want to call it, is asking for an angle whose cosine is negative 1/2. And the range of an arc cosine function is here to here. So you can only answer when is the x value that in this region. And so you get right there at 2π/3. And yes, I have it twice. All right, now number 2 and 3. All right, so this overall, this is an arc sine function. Arc sine can produce an answer. Let's see, in this region here. So I cannot just cross these off and say the answer is 5π/3, because 5π/3 goes around to the dead area and then gets to here, where I do want that spot, but it can't call it 5π/3. I have to get to that spot by going this way. All right, whereas tangent, this is a tangent function. So what's the range of a tangent function? Well, a tangent function just goes up and down forever, up and down forever. So you can have an answer of π/3 for that. So this one basically just cancels each other out and you say the answer is π/3. Whereas this one here, 5π/3 is not in the range of this function. So your best bet is to work it out. The sine of 5π/3 is negative radical 3/2. And then the arc sine of negative radical 3/2, if I look here, oh, the sine is negative radical 3/2 right there. So down π/3. So there you go. All right, down here. Now, I forgot to say in this problem for all real numbers or from 0 to 2π. So I'm just going to go ahead and say it's for all x. All right, that could be true. All right, I got to get rid of the radical 3. So I got tangent of x plus π/4 equals negative 1 over radical 3. So I have to apply an arc tangent or inverse tangent to the tangent to get rid of it. So these knock off and get me x plus π/4, but now I have to do the arc tangent of that over there. All right, so when is the tangent equal to negative 1 over radical 3 in this region? So that would be at a π/3 angle, but no, π/6, sorry, this over that, but it's down here because it's negative. So this over that makes negative 1 over radical 3. So that's negative π/6. Now, since we're doing for all x, the period of tangent is pi, so we're going to say plus pi k, where k is an integer. So I just got to subtract π/4. So x equals, I'll say plus pi k. I got to do negative 1/6 minus 1/4. So negative 1/6 minus 1/4. Let's get these to 12s. So that's negative 2, 3/12. So that's negative 5/12. All right. Okay, over here, I'm applying a cosine to both sides. So I'm doing the cosine of this side and the cosine of that side to get rid of these. So 4x pops out. I can do the cosine of anything. There's no like restrictions like there were here. So cosine of π/6 is radical 3/2. So I just got to multiply by 1/4 to get rid of the 4. I don't want to divide because there's already a fraction here. So I'd say x equals radical 3/8. Okay, so down below here, this really tiny unit circle here, I want to know when the sine is less than negative 1/2. So remember, sine is the y value, right? And so when is the y value less than negative 1/2? So negative 1/2 is here. So basically anything below this line. So we're looking for this region right there. All right, so basically anything below here, so we're looking for this region. Now when I name the area, I have to go from 0 to 2π. So I'm starting at 0, I'm going around, up, there's answers from here to here, and then it stops. So from 7π/6 to 11π/6. And not equal to, so parentheses, theta is in that region. You can also write an inequality if you rather. All right, down here, when is the cosine greater than radical 2/2? So cosine is an x value. So radical 2/2 is right there. So here and here. So basically any region that's passed to the right of my line right here. So to the right of this. All right, so this, when I start at 0, it basically gives me this area, then it stops, and it gives me this area. So I have to say 0 to pi over 4, and then I have to pick back up at 7 pi over 4 to 2 pi. It says equal to, so I can put brackets here, and it says equal to there, or this, but 2 pi is not included, so I'll put a parentheses. So theta has to be in that element, an element of that set. All right, so number 8 is basically asking me to set these equal to each other. So 2 sine theta equals negative 1/2. So the sine of theta equals, oh, I just did it in my head, sorry, this is just negative 1. So negative 1/2. So when is the sine negative 1/2? And we're looking for all the values from 0 to 2 pi. So this is stated, so yes, I'm doing the arc sine in a way, but the way this question is posed is it's asking basically for all the things from 0 to 2 pi that make that true. So yes, we're doing arc sine, but we're doing it more in this unit circle way. All right, so that happens at these two places, letter D. All right, other side. So when does, let's see, the graph, which of these, so tangent, all right. So tangent graph. So remember these graphs, we got tangent, right? So the normal asymptotes for tangent are negative pi over 2 and positive pi over 2. Well, obviously not 3 pi over 4. So these things have been shifted. So if you remember your graph, you know, tangent x is not it. It doesn't have a vertical asymptote there, so it's not that one. So if I move to the right by pi over 2, well, this much is pi over 2. So I've moved to the right by pi over 2, that's going to be pi. So this one doesn't do it. How about to the right by pi over 4? Well, if I take this and move it to the right by pi over 4, there's my 3 pi over 4 right there. So it is letter B. So one way to do this is to remember the pictures. Another way to do it is to literally like plug this in and see if you can do the tangent. So if you can't do the tangent there, then that's an asymptote. So if you put 3 pi over 4 right here, the tangent of 3 pi over 4 is totally doable. It's negative 1. All right. If you put 3 pi over 4 here, well, 3 pi over 4 minus pi over 2 is going to be pi over 4, and that's doable. Whereas here, 3 pi over 4 minus pi over 4 is 2 pi over 4, which is pi over 2. Tangent's undefined there, so that's why that one doesn't work. All right, let's see. So this guy, I'm solving this. So I'm going to bring this over to the other side. So I get 2 sine squared plus sine equals 0. So I'm going to factor a sine out, which leaves me 2 sine plus 1. All right, so I got the sine is equal to 0, and then this would produce sine equals negative 1/2. So we're just looking for the places in the unit circle where this is true. All right, so when is the sine 0? Here and here, 0 and pi. When is it negative 1/2? 7 pi over 6 and 11 pi over 6. So B, yeah. All right, so we're solving this equation. So when is this equal to 0? So I notice that this sine 2x, so basically it's sine 2x minus cosine equals 0. But this is your double angle formula, right there. So I'm going to change that to 2 sine x cosine x. And now I notice I have a cosine to factor out. So I factor that out, which leaves me 2 sine x minus 1 equals 0. So when is cosine equal 0? And when is sine equal to 1/2? All right, and this is asking for all values. So the periods of these are 2 pi, so I'll have to say plus 2 pi k. So cosine is 0 here and here. So you could say pi over 2 plus 2 pi k and 3 pi over 2 plus 2 pi k. Or, look, these are a pi apart. So I could just reduce that down to pi over 2 plus pi, plus pi k, if I don't want to write them both. And then one is sine 1/2, that's pi over 6, and 5 pi over 6 plus 2 pi k. So you can list all 4 separately, or like I said, you can put those 2 together. All right, so number 12. 12 is the worst. Okay, so inequality, and this one's a little bit hard, and it's going to be like a little calculator work, and I know I said no calculator, but the one on the test, I'll make sure that they're kind of easy values that you don't need the calculator for, or they're easy to see. But here we go. Or I'll let you use a calculator on that one problem if I have to. All right, so I need my critical numbers because inequalities need critical numbers. We're going to have to make a number line out of those critical numbers starting at 0 and going to 2 pi. All right, so critical numbers are when this equals 0. So basically when the sine is negative radical 2 over 2, or when the cosine is 1/2. Okay, so the answer to negative radical 2 over 2 is going to be 5 pi over 4 and 7 pi over 4. And cosine is 1/2 at pi over 3. And 5 pi over 3. So these are my critical numbers, and I got to put them in order on my number line. All right, so the smallest is pi over 3. 5 pi over 4, 7 pi over 4, dang it, nope, 5 pi over 3, and 7 pi over 4. I mean, you could also, you just look at your unit circle and see which one comes first. All right, so 0 to pi over 3, I have to pick something in this area that is I have to do the sine or cosine in this area and plug them in here and see if it's positive or negative. So is it greater than or equal to 0? All right, so from 0 to pi over 3, let's look at the y values. So here to here, y values, the easiest one is 1/2. So 2 times 1/2 is 1. 1 plus radical 2 is positive. Cosines, so the easiest cosine there, I don't know, let's do radical 3 over 2. It doesn't really matter because there's no easy ones. So radical 3 over 2, 6 times radical 3 over 2 minus 3. That's going to be 3 radical 3 minus 3. So this is bigger than that. So it's positive. So 2 pluses means that area is positive. All right, from pi over 3 to 5 pi over 4. That's a nice one. So it's basically this whole area. So any y value in this whole area. So I'm going to use these numbers right here. So a 1. So 2 times 1 plus radical 2, that's positive. I don't even care what it is, it's just positive. 0, if I put a 0 here, I get negative 3, that's negative, so this area is negative. All right, 5 pi over 4 to 5 pi over 3, so that's here to here. So I'm going to use these numbers. All right, so this one's not too bad. Negative 1 for right here, so it'd be negative 2 plus radical 2. So radical 2 is smaller than 2, so negative 2 plus that would be negative. All right, and then using 0 here, I would get a negative. So 2 negatives is a positive. All right, now this is the worst part. From 5 pi over 3 to 7 pi over 4, that's like a little tight area right there. So I need a y value that's between these numbers. So let me tell you, negative radical 3 over 2, and negative radical 2 over 2. All right, this is what I'm talking about, the calculator. So I need a y value that's between these. So I'm just going to say 0.8, all right, negative 0.8. So if I had negative 0.8 times 2, yeah, sorry, I was just thinking, that'd be negative 1.6. So negative 1.6. And radical 2 is 1.14, I think, whatever. Radical 2. So you see how that comes out to a negative number. All right, now if I need a cosine value, so I need an x value between these two. So 1/2 is 0.5. So I'm pretty sure I can use like 0.6 or whatever, because it's probably not radical 2 over 2. Yeah, look, it's 0.7. So I'll just use 0.6. So 6 times 0.6, that would be 3.6, because 36 with the decimal place in the middle. 3.6 minus 3 is positive, so it's going to be a negative area. All right, now this area right here, from here to here, so let's use negative 1/2 for my y value. 2 times negative 1/2 is negative 1. It's not big enough to take that over, so it's positive. And then this area right here, these cosines right there. Where am I? 7 pi over 4. So anywhere in this region. So I'm getting really close to 0, the y value of 0. So I'm going to just say, you know, no, I'm sorry, cosine. I'm really close to 1. So I'm just going to say like 0.9 or something. So 6 times 0.9 would be almost 6. 6 minus 3 is positive. So that's plus. All right, so after all that, 5 hours later, I now can see which areas are positive and negative. So I want the areas that are greater than or equal to 0. So I want this area, and that area. So I want my theta to be from 0 to pi over 3, or from 5 pi over 4 to 5 pi over 3, or from 7 pi over 4 to 2 pi. I will allow 0, so therefore we will say we will allow these numbers here, and we allow 2 pi. All right, there we go. All right, here we go. Cotangent. So for this, you either do one of two things. You remember the cotangent graph. 0 and pi are my asymptotes. They are getting the period of cotangent is normally pi. That's getting divided in half. So basically your period is getting divided in half. So now 0 to pi over 2, those are your asymptotes. And then this question says which is a vertical asymptote, and there it is. All right, so you can do that. Or, like I did earlier, you can try plugging in these numbers. Let's do pi over 4. So cotangent, 2 times pi over 4 becomes pi over 2. So the cotangent of pi over 2 is 1 over the tangent of pi over 2. All right, so the tangent of, well, now I'm confusing myself. Hang on a second. All right, let's just forget about that. Let's just do the cotangent of pi over 2. Tangent is 1 over 0, so cotangent would be 0 over 1, so that's just 0. That's doable. If you put a 2 in here, the cotangent of 4, that's just like a value to calculate in your calculator, that's okay. If you put 5 pi over 4, that would be the cotangent of 2 times 5 pi over 4, so 2 times 5 pi over 4 will be 5 pi over 2. So the cotangent of 5 pi over 2. 5 pi over 2 is 4 of them to get around and 1 more, so that's here again. So that's doable. So this is doable. These are all doable, right? But this one is not, because if you put pi over 2 in here, you get pi. The cotangent at pi, this over that, is undefined. All right, so, I mean, same thing here, like plugging in 1. So either you remember the cosecant graph. This is all cosecants and secants. So here's cosecant goes with sine, remember? And secant goes with cosine. All right, anyway, so cosecant, let's have a vertical asymptote. So when you put a 1 in here, that's like 1 over the sine of 1, which is like just like a random number to do the sine of, which is possible. Here, this is put a 1 in here. You're getting the cosecant of pi, which is 1 over the sine of pi. All right, well, the sine of pi is 0, and 1 over 0 is not possible. All right, secant of pi would be like 1 over cosine of pi, and that is -1, so that is okay to do. And here, secant pi over 2, so that's 1 over cosine of pi over 2. Well, cosine of pi over 2 is 0. Oh no, 1, sorry, not pi. So this is 1/2, this is 1/2. Yeah, cosine of 1/2 is just like a number you need for your calculator for, like you don't know that by heart. Right. Anyway, let's let it be. Okay, So secant. So again, you could remember the graph, or also remember that secant is just going along with cosine. So this graph, the midline of this graph right here, if you think of a cosine graph, it'd be 7, and then it's going 3 above and 3 below. So 10 and 4. But basically that cosine graph that's in here, the secant graph is going off of that. So it's going up here and down here and up here and down there. So it's staying out of the region where the cosine graph would be. Or you can say to yourself, hey, we got a secant graph. It's being stretched to 3 and -3, and then it's been moving up 7. So either way, you got there. All right, here we go. So cosecant. So your asymptotes. Cosecant goes with sine. So sine function looks like this. So the asymptotes are at 0 and pi, the first two asymptotes. Well, this 4 is going to basically take this asymptote and dilate it in, right? So if your asymptote's at pi, now it's at pi over 4. So that's my first asymptote. And remember the period? The period of cosecant is 2 pi. So the period is 2 pi over 4. So that's pi over 2. So the period's pi over 2, but remember that accounts for this whole thing. So what's going to happen is in the period, in the whole graph, because remember the graph is here and here, in the whole graph, I also have another asymptote at a halfway point. So what's half of pi over 2? Well, that's pi over 4. So pi over 2 is going to be, 0 and pi over 2 are the outer asymptotes, but there's also one in the middle, because that's where sine crosses 0 also. So your sine function would be like right in here, and then your graph would be there. Okay, so anyway, letter B. All right, what is the value of h of pi? So we're going to plug pi in there. So 6 minus 5 secant of pi over 3. Well, the secant of pi over 3 is 1 over the cosine of pi over 3. And the cosine of pi over 3 is 1/2. So 1 over 1/2 is 2. So 6 minus 5 times 2. 6 minus 10 is -4. All right. I am getting tired here. Let's see. Okay. Let's see. I got this and this. Points of intersection. So I'm just solving this, right? So 1 plus 2 cosecant squared equals 9. So take away 1, that's 8. Divide by 2, that's 4. So cosecant squared equals 4, square root. So I got cosecant squared equals plus or minus 2. Well, the cosecant, oh, I did the square root, so it's not squared anymore. So the cosecant's plus or minus 2, that means that our friend, the sine, is plus or minus 1/2. So that's what we're going to figure out. So those are all of your pi over 6s. So those 4 answers. All right. Okay, so, all right, this guy. So we're going to square this. We're going to multiply that by itself. So we got sine theta plus cosine. So remember when you're squaring it, multiply it out. All right, so sine times sine is sine squared. I got sine times cosine is sine cosine. Then I got another sine cosine coming here. So I have 2 of them. And then in the end I have plus cosine squared. So this is all minus 1 over sine and cosine. Well, sine squared plus cosine squared, that's equal to 1. So I could kind of combine that and say, oh, that's equal to 1. So now on the top I have 1 plus 2 sine theta, cosine theta, but I also have a minus 1. So those ones cancel. And now that they're gone, I can cancel these, and there's my 2. All right, let's just show that this is equivalent to that. So, I don't know, let's multiply this out. So cosine squared, and cosine squared times tangent. So I got cosine squared, tangent is sine squared over cosine squared, So that's going to be that. And let's see, I guess I have that wrong. Show that it's equivalent to 1, that should say. Oops. Alright, so anyway, there you go. Because this is cosine squared plus sine squared. Alright, which is 1. Okay. 5 and 2 pi over 3. So it means there's circle 5, 2 pi over 3 would be about there. Write 2 different representations for this point. Alright, so I think I can come out to 5 and go backwards. So 1, 2, 3 pi over 3, 4 pi over 3. So 5 and negative 4 pi over 3. Or I could go backwards 5 and go backwards pi over 3. Yep, okay. And there can be many answers. Alright, average rate of change from 0 to pi over 3. So remember these right here, we go ahead and graph this and see what's going on. So the midline is 1 and it goes 2 above and 2 below. And the cosine graph starts here and ends at 2 pi. So there. So let's see, bottom, middle, there. Alright, so from 0 to pi over 3. Well, this is going to be pi. So, you know, pi over 3 would basically, it might be about like right there, but it's going to be this little part right there, right? So this part of the graph is above the x-axis. Oh my gosh. It said average rate of change. I'm sorry. I thought this was saying is it increasing or decreasing. My bad. So you don't have to do this at all. All right. So average rate of change means I need to do r of pi over 3 minus r of 0 over pi over 3 minus 0. That's my average rate of change. All right, so plug pi over 3 in here. Cosine of pi over 3 is 1/2. 2 times a half is 1. 1 plus 1 is 2. Put a 0 in here. Cosine of 0 is 1. 1 plus 2 times 1 is 3. And this will be pi over 3. So I get negative 1 over pi over 3. So this turns into negative 3 over pi. And there you have it. All right, almost done. Yay. All right, so this guy. Let's see. This I notice is symmetrical over the y-axis, so it must be some kind of sine function. So let's see. Not this, not that. This is one of the flower graphs. This is a rose petal because it doesn't have the plus minus, so it's not that. So here, notice how the sign is reflected, so it's the one with the negative. There we go. So I'll just make it that easy on the test. All right, polar coordinates. What are the xy coordinates? So the first job is to figure out where this is. So 4 and 5 pi over 6 is maybe about there. So I needed something in the second quadrant. So we got r cosine theta and r sine theta for my x and my y. All right, the radius is 4. Cosine of 5 pi over 6 is negative radical 3 over 2. So I get negative 2 radical 3. So left, that's good. All right, 4 sine is 1/2, so that's 2. So negative 2 radical 3 comma 2. There you go. All right, over here in the polar coordinate system, which of the following is the average rate of change the least? All right, so A to B. So A to B, it goes in, it comes out. So we're looking at the way you get closer to the middle or further away. That's your R value decreasing and increasing. Well, this is just a wash. It's decreasing, then it's increasing. So let's just cancel each other out. All right, C to D. Again, well, here I'm getting further away from the center, and then I'm getting closer to the center. All right, B to C. B to C, I'm getting further out, so that is greater than that. D to A, I'm coming in, so that's the least. My average rate of change is decreasing instead of increasing, so D. Oh my gosh, almost done. All right, so let's see. All right, which of the following describes Okay, well, -1/2 and so it's up here, right? So I need one of these points to be in the second quadrant. So 1 and pi over 3 is not. 1 and 5 pi over 6, maybe. 1 and 2 pi over 3, maybe. 1 and 4 pi over 3 is down here, so no. All right, so I'm not gonna do my R value because obviously it's 1, but I need to know what angle I'm at. So my angle is my y over my x. So tangent theta, my y over my x. If I take radical 3 over 2 over -1/2, well, so I don't know, you guys. This is the x and the y. You can just recognize this from the stupid unit circle. It's right there. It's 2 pi over 3. All right, or do this work and then you'll get back to 2 pi over 3. All right. Here, a complex number. Okay, so this is basically my a and my b. So this is negative radical 3 plus 1i. So this is a complex number. So my r value is x squared plus y squared equals r squared. So if you square this, you get 3. You square that, you get 1. So r is basically plus or minus 2. Remember, I need to create something that's in the second quadrant. Now, a lot of these have been in the second quadrant, but I don't know, it's not common. So then I do my tangent. Tangent of my angle has to be my y over my x. So 1 over negative radical 3. So my angle is some kind of, let's see, 1 over radical 3, that's going to be a pi over 6. So some kind of pi over 6. I guess this could say negative pi over 6. But basically, I know that I'm at a pi over 6 angle in the second quadrant. So I'm going to say that I'm at 2 and 5 pi over 6. Or you could say -2 and negative pi over 6, because that would also put you negative and up here. Okay, so either way. All right, this guy here, last one, recognize that that's just your cosine trick right here, or sum or difference. So this is going to be the cosine of the subtraction of these two things, 13 pi over 12 minus 5 pi over 12. So that would be the cosine of 8 pi over 12, which is 2 pi over 3. So cosine of 2 pi over 3 is -1/2. And there you go. All right, that is it. I hope you did not watch this all the way through because that would be quite boring. All right, I'll see you in class. Bye-bye.